Household circuit. Transmission of power from the generating station to the consumer. Power generating station at 11 kV gives to grid substation step up to 130 kV, gives to main substation step down to 33 kV, gives to intermediate substation step down to 11 kV, gives to city substation step down to 220 volt, gives to the consumer. Distribution of power to a house. The cable has three wires: live or phase wire denoted by L, neutral wire denoted by N, and earth wire denoted by E. Neutral and earth wires are at the same potential, that is at 0 volt. Live wire or phase wire carries current from the source to the distribution board. Neutral wire is for the return of current back to the source. House wiring ring system. The ring system of house wiring shows circuit for lamp socket and fan with fuse and switches in the live wire. Advantages of ring system. The main ring wire being thick, the wire required for connection of some devices is of a lower current carrying capacity than that which would be required for a direct connection to the mains. This reduces the cost of wiring considerably. Each appliance has a separate fuse, therefore, if due to some fault the fuse of one appliance burns, it does not affect the operation of other appliances. At the plugs and sockets used can be of same size, but each socket should have its own fuse of rating suitable for the appliance to be connected with it. While installing a new appliance in a room, a new line up to the distribution box is not required, but it can directly be connected to the ring circuit in that room. If for any reason the wire breaks, the alternate route for supply due to ring circuit ensures that appliances still continue to work. Advantages of connecting the appliances in parallel. Each appliance gets connected to 220 volt supply that is equals to its voltage rating for its normal working. Each appliance operates independently without being affected by the presence of working of other appliances. Disadvantages of connecting the appliances in series. The voltage of the source gets divided in all the appliances connected in series. On connecting one more appliance in the same circuit, the resistance of the circuit will increase. Hence, it will reduce the current in the circuit, so each appliance will get less power. All appliances connected in series operate simultaneously. If one appliance is switched off or not operated, no other appliance connected with it in the series will then operate. Fuse. An electric fuse is a safety device which is used to limit the current in an electric circuit. The use of a fuse safeguards the circuit and the appliances connected in that circuit from being damaged. Principle: a fuse works on the heating effect of current. Material of a fuse: an alloy of lead and tin is used as the material of the fuse wire because its melting point is low, that is around 250 degrees Celsius, and specific resistance is high, more than that of copper, aluminium, etc. Reason for connecting the fuse in the live wire. The fuse is always connected to the live wire before the appliance, so that as the current in the circuit exceeds the rating of fuse, it melts and breaks the circuit first, before the current reaches the appliance. Thus, no current flows in the appliance. MCB, miniature circuit breaker. Nowadays, instead of fuse, a miniature circuit breaker MCB is used in each individual circuit. MCB is more convenient than a fuse because it avoids the inconvenience of combing a new fuse wire. It is much safer than a quick response. Switches. A switch is an on-off device for current in a circuit or an appliance. It is connected to live wire. Single pole switch. The switch used with an appliance to start or stop the flow of current in it is the single pole switch. A single pole switch disconnects only the live wire from the appliance. Double pole switch. The main switch at the distribution board used to switch on or off the mains is the double pole switch. A double pole switch disconnects both the live and neutral wires simultaneously. Circuits with dual control switches. Staircase wiring. Dual control staircases are usually found on the staircase. Figure A, B and C show the operation of such an arrangement. In figure A, switch S1 has poles A, B connected to S2 has poles BC connected. The bulb does not glow. In figure B, when the switch S1 is operated, that is connection AB moves to BC, the current flows in the circuit. The bulb glows. Now in figure C, when the switch S2 is operated, that is connection BC moves to BA, the bulb turns off. In this way, a person moving on a staircase can turn on the light from one and turn it off from other. This saves the inconvenience of going up and down to switch on or off the light. These days, dual control switches are also used in bedrooms, etc. to operate switch either from entrance of room or from bedside. Earthing, grounding, local earthing, safety by the local earthing. If due to some reason such as short circuiting, an excessive current flows during the line wire, it will pass to earth through the earth wire if there is local earthing. Otherwise, the line wires may get overheated and it may cause fire. Earthing of an appliance. It is essential to provide a good earthing connection for an electrical appliance such as refrigerator, toaster, geyser, electric iron, electric cooler, etc., which we handle physically. The outer metal case of these appliances that provides with a terminal on the case. The earth wire of the cable is connected in this terminal. 3-pin plug and socket. 3-pin plug. In the 3-pin plug, the top pin is for the earthing, the pin on the left is for live, and the pin on the right is for neutral. The earth pin is thicker and longer than the other two. The earth pin is made long so that the earth connection is made before the live connection. The earth pin is made thicker so that even by mistake it cannot be inserted in the hole of the live or neutral connection. Socket. The socket has 3 holes. The upper bigger hole in the socket is for earth connection, while the hole on the right side is for connection to the live wire and the hole on the left side is for the connection of the neutral wire of the electric supply. Safety precautions for plug and socket. While inserting the plug into a socket, the following 2 main precautions are taken. The hands must be completely dry. The plug pin should fit in the socket tightly. Any loose connection will give rise to sparking and burning the either of the socket or plug. Color coding of wires and cable. Wire live. Old convention red, new convention brown. Neutral, old convention black, new convention light blue. Earth, old convention green, new convention green or yellow. High tension wires. A wire having a low resistance and high surface area is known as high tension wire. The resistance is kept low so as to allow a heavy current to pass through it. A high tension wire is generally made up of various thick wires that are twisted on each other as shown in the figure. This gives the wire a greater surface area to dissipate the heat generated and also helps in lowering the resistance of the cable. The twisted adds strength to the cable too. Thus, high current can be passed with minimal losses through the wire. Safety precaution while using electricity. While using the electricity, precautions are taken to avoid the 2 major dangers: a fire and electric shock. To avoid a fire, one must use wires or cable of current carrying capacity higher than total current which can flow through the circuit while using the appliances simultaneously. Avoid an electric shock. 5 precautions are taken. The insulation of wires must be of good quality and it should be checked from time to time because the insulation over the wire becomes brittle with the passage of time and it cracks off, leaving the wire naked. The appliance should never be operated or touched with wet hands. The hands should always be kept dry. Each appliance must have its metallic case earthed. Each appliance must be provided with a proper fuse in its live wire before the appliance. There must be proper local earthing near the kilowatt-hour meter.